it's Astrodude here. I was very honored to have the privilege and pleasure of speaking with Dr. Robert Zubrin. He's a renowned aerospace engineer, author, and the founder and president of the Mars Society. And he's an advocate for human exploration of Mars and more. He was very gracious with his time, and he supports young learners like me who are interested in science, technology, engineering, and math. And I am very grateful for the time that he spent with me. It was a great time speaking. So now let's get into the video. I hope you guys enjoy.
Okay, hi guys. So this is Robert Zubrin, the author of the Case for Space, and he's on. So, what makes the SpaceX Starship development program different from other development programs?
Well, it's very different. First of all, it's being almost entirely privately funded. Second of all, the ambition behind it is tremendous, which is to create a fully reusable heavy lift launch vehicle. Moreover, that runs on a propellant that can be made on Mars, so it can fly to Mars, and it can be fueled there and fly back. And the third thing is the remarkable speed with which this development is occurring. And the fourth is the methodology, which is build, fly, crash, build, fly, crash, fix what went wrong, do it again. They've already set up a production line for these things so that they're prepared to take losses and just push on through. This program is more reminiscent of the early days of aviation than the space program, at least since the dawn of the space program.
And what's your thoughts on the program right now? What they're doing with Booster 3?
Well, I'm not exactly sure what they're doing with Booster 3, but clearly if the thing's going to make orbit, they have to get the Super Heavy to work, not just the upper stage, the Starship proper. So who knows? But it certainly looks like they're preparing to be able to fly the two of them together this fall.
And what's your thoughts on the idea of applying air-breathing propulsion to the Starship Super Heavy system?
Oh, I don't think applying air-breathing propulsion to the Super Heavy makes a lot of sense. If you're talking jet engines, they have a much lower thrust to weight than rocket engines do, and the Super Heavy needs thrust, and thrust we trust. And an air-breathing system would be a different kind of system, actually. Air-breathing system might be interesting for an upper stage system like a Starship or the upper stage of the Falcons to enable them to do long-distance hypersonic flight, because the first stages of the Falcons or the Super Heavy take you right up into that regime. And then if you wanted to do long distance surface to surface, you might consider such a thing, or else just do ballistic flight as they're doing. Or it could be an alternate type of system. I don't think the Starship needs it, but someone else might go for it.
And how do you think the new companies such as Rocket Labs and Relativity Space, do you think they have the potential to become like SpaceX?
Well, maybe. The Rocket Lab certainly has been impressive. And one thing I really like about Rocket Lab is that it was started by working engineers, not billionaires, just people who managed to, with the strength of their ideas, mobilize investment capital and do it. Now, it does put them at somewhat of a disadvantage compared to SpaceX, in that it would be very difficult for Relativity or Rocket Lab to do the kind of development program that Musk is doing. They can't afford to keep on making things and crashing them. This would tend to slow them down, that they have to adopt more frankly, traditional approach of doing a great deal of analysis before you attempt to fly one of these things. But certainly, Rocket Lab's impressive, and also the fact that it's a New Zealand company. New Zealand just reached orbit, and they don't even have a space program.
What so fully and rapidly reusable rockets is right now considered kind of like the holy grail of rocketry, but what would be like the next big steps after that for rocketry?
Well, that's an interesting question. Rapidly reusable rockets would certainly be pretty damn good, and that, of course, is Musk's goal. And and if he's also rapidly building them, shuttles, they built 5 of them over 30 years. He's building Starship prototypes at a rate of 1 a month, and so once this thing's operational, it's pretty easy to see how he might have 50 or more of them operating at any one time. And if each one flies once a month, that's 500 launches in a year, which is spectacular. And in fact, he's going for metrics well beyond that. Starships, as we see them in the relatively near term, are going to create massive payload capabilities to orbit, intercontinental flight capability as well. And if they can be refueled on orbit, and I think they've got a fairly good concept that should enable that, then they can fly to Mars. And then the issue is building a Mars base, initially sending a large, a battalion of robots to build the base before you send the people. And you land a few starships on Mars flying one way, but they're just delivering all the payload. And those starships themselves can be used as fuel depots. That is, they have very large tanks, and you could just, once you get the in situ propellant production going, you could fill them up. Once you've got a supply of methane and oxygen already made on the surface of Mars, it's time to send the people.
And so you have a patent called nuclear saltwater rocket, which would be like a next step in rocketry. Can you? It's okay if you could like explain how you came up with it, its capabilities, and how far away are we from it technologically?
Well, the basic idea is to have a steady state, fast fission reaction going on. In a nuclear fuel, like in an atom bomb or a nuclear reactor, has about 1 million times the energy per unit weight as any chemical fuel, in round numbers. And if you had 100 times the unit weight per unit fuel, then you would get 10 times the exhaust velocity. So 10 times the exhaust velocity of a chemical rocket, they have exhaust velocities about 4 kilometers a second, go to 40 kilometers a second. That's comparable to electric propulsion. And so, but 100 times the energy of chemical propellants is actually less than 1,000th of the energy of a nuclear fuel. So basically, in an atom bomb, for example, they want to have yields of over 50%, of more than 50% the energy that's there in order to have big. But we don't need 50%. We don't need 10%. We don't need 1%. We need about 1% of 1%, and we can create a rocket with an exhaust velocity 10 times that of the best possible chemical engine. And that's basically the idea of the nuclear saltwater rocket. It's basically a continuous nuclear fizzle.
And so speaking of nuclear energy, how do you think nuclear fusion will benefit humanity? And is there any particular nuclear fusion reactor design that you find to be the most promising?
Well, Okay, look, nuclear fusion will end all talk about energy shortages or about economic growth constrained by the fact that using more than a certain amount of fossil fuels could have environmental impacts or anything of this kind. We're talking about infinite energy relieved of the constraints of conventional pollution, global warming, or anything of the kind. And we're also talking about very cheap fuel. I mean, 1 gallon of seawater contains about the same amount of energy of 350 gallons of gasoline if you could use the deuterium that is in it. Now, by the way, if that was Martian water, it would be about the equivalent of 2,000 gallons of gasoline because Martian water is 6 times as rich in deuterium as Earth water. Now, so that's pretty spectacular. And in fact, I think that's one reason why the Mars colonists are going to develop fusion power. It is the energy resource that is abundant on Mars and requires much less industrial processing than, for instance, producing fission fuels like uranium or thorium. Isotope enrichment of deuterium, which weighs twice as much as a hydrogen, is much easier than isotope enrichment, say, of uranium, which differs by about, the different isotopes differ in mass by 1%. So the fusion will, it's not just more energy, though, it's a different kind of energy. This is important, that you take nuclear fission. Nuclear fission, they have nuclear fission power plants, but it hasn't been a rip-roaring success. It's found a place in the market. One could debate whether it could be more or should be less or something. But the one place where nuclear fission has taken the world by storm is submarine propulsion. That is, there's a lot of ways to produce electricity for your wall socket. You could do it with nuclear fission or with a coal-fired power plant or a windmill or a waterfall, and as far as the consumer is concerned, the kilowatt's a kilowatt, doesn't make any difference at all. But nuclear power on a submarine has unique advantages over, a diesel electric submarine. It can travel around the world underwater. The other thing, it can most spend 20 hours underwater. So it is qualitatively superior. And the same is true with fusion. That is, you could do submarines, but you could do other things. You could do fusion rockets, because a fusion rocket could have an exhaust velocity about 10% the speed of light. So, in fact, that's a lot more than the saltwater rocket. We're talking about instead of 40,000 kilometers a second, which would be, in other words, the chemical rocket's 4,000 kilometers a second exhaust velocity. Saltwater rocket, maybe 40,000 kilometers a second exhaust velocity. I'm missing something here. Speed of light is only 300,000 kilometers. So 30,000 kilometers a second. So we go from 4 kilometers a second to 40 kilometers a second to 40,000 kilometers a second. That's the difference. That's what you can do with fusion. Saltwater rockets would give you very easy transportation around the solar system. Nuclear fusion rockets are as an entry capability to interstellar travel.
Okay, so when we talk about transportation, so we have a lot of transportation options on Earth. What kind of transportation options would people have on Mars?
Oh, that's interesting. I think, for short distance travel, we could have, first of all, vehicles like all-terrain vehicles. It's ride them in the saddle in your spacesuit, and also pressurized rovers, things the size of SUVs. But if you want to travel further than that, I think we're going to have helicopters on Mars. Ingenuity has just proven the principle of it. And, so Ingenuity is the size of a toy helicopter. But, the Sojourner rover of 1997 was the size of a toy car. Now we got rovers the size of real cars on Mars. And, 30 years from now, we'll have helicopters, not just the size of toy helicopters, but the size of real helicopters, and people will be able to fly them around Mars. And for true long distance travel, then rockets, surface to surface.
So when we're talking about not nuclear energy, but transportation for interstellar travel, one of the things that a lot of people bring up is warp drives. How practical do you think warp drives are?
Well, we don't have a physical, we don't have physics that allow them yet. Now, so I'm an engineer. I use the physics that we've got, but I do suspect that the fissions that we've got is incomplete. That is, in 1895, somebody in the patent office thought that everything that could be invented was. Because we had a pretty good understanding of, mechanical machines and gears and things, and also steam engines and thermodynamics, and even electrical generators. And gee, if you know all that, what else is there? Well, turns out there's other things beyond that. And a lot of things were invented in the 20th century that were unimaginable in the 19th century. And, these computer devices that we have take advantage of quantum mechanics, which are unknown. One was unknown in 1895. Of course, nuclear power was unknown. The people did not know what could possibly be powering the sun in 1895. And that's an interesting fact, because it didn't bother that many people that they didn't know what could power the sun, which of course is fundamental to human existence and all life on Earth. And they didn't know, but they thought they knew everything, even though they didn't know the foundation of the thing that was keeping them alive. Well, okay, we talk about the Big Bang. What made that happen? Okay. We have physics that say matter and energy cannot be created or destroyed. But they clearly were. We're surrounded by matter and energy. Okay? That's the most basic fact of our existence. We're composed of matter, and we don't know how it was made. In fact, our physics says it can't be made. Okay? But clearly it can't. So therefore, our physics is incomplete. And when we actually learn more physics, it will give us capabilities that would seem magical today, just as what we can do today would seem magical to someone from 1895. And frankly, what people were doing in 1895 would have seemed magical to someone from 1695, because in 1895 they had telephones.
So when we talk about expanding into the universe, can you explain how that would benefit our civilization?
Sure. It'll multiply our civilization. We're going to have new civilizations, more civilizations with new languages, new literatures, new customs, new ideas on human social organization, and making innumerable diverse contributions to science and technology. Okay, this is how we're going to benefit from Mars. We're going to go together to Mars, and then we're going to go further together with Mars.
So I'm a member of the Mars Society, and what is the goal of the Mars Society?
Well, the goal of the Mars Society is to further the exploration and settlement of Mars. And we do that by spreading the vision, by doing political work, and by projects of our own, such as the Mars stations that we have in the Arctic and the desert.
And what is your message for students like me who are studying to become an engineer?
I'm saying that you are very lucky if you choose to be, because you are present at the creation. You are living at the beginning of history. Back in the 90s, somebody wrote a book which he called The End of History, which was one of these books of how everything important has already been done. Well, he could have been more wrong. We're not living at the end of history. We're living at the beginning of history.
And do you think Mars is the most important place to colonize in our solar system, or do you think there's other places that could potentially be better?
I think Mars is within our solar system. It is the closest world that has on it all the materials needed to support life and civilization. And we can get there with present day propulsion in 6 months. And that's short enough, frankly. That's how long it took to sail from England to Australia in the 1800s. Hundreds of thousands of people made that trip. Eventually, we'll go faster. Grandchildren of the first Mars settlers will wonder at the tales of their grandparents of 6-month voyages in cramped ships between Earth and Mars, just like some of us who are of immigrant heritage hear the stories of our grandparents coming across the Atlantic, and the holds of the immigrant steamships, eating the orange peels thrown down to them by the first class passengers, so forth. Well, we just make the trip in 6 hours today and sitting in a comfortable chair. Well, the grandchildren of the first Mars immigrants will listen to the tales of the settlers with wonder, because they're going to do it in 3 weeks in fusion-powered spaceships, okay? But and doing it in comfort and all the rest, okay? Billiard tables and hot tubs and all that shit. But it takes those people, okay. My grandparents' generation, they're coming in steamships, and the people who came a century before them came in sailing ships. 3-month voyages across the Atlantic and being tossed about and so forth, okay? But they did it. The oceans were opened up not by wooden men and iron ships, but iron men and wooden ships. And that's how it's going to be with the solar system.
So when we talk about flying to Mars, what do you think the comfort is going to be like? The conditions that the first cruise to Mars are going to have to undergo?
I think it's going to be tight. It's going to be tight. We're going to be constrained in volume and mass, and nobody's going to be taking 5-minute hot showers. Take sponge baths so that we have reduced the amount of water we need to recycle. It's going to be tough. The first people that go to Mars are going to have to rough it. But they will show the way. And, look, Columbus crossed the Atlantic in ships that even 50 years later, no one would have crossed the Atlantic, and they would have thought someone was crazy. Even 50 years after Columbus, going in the kinds of ships that he went. Because when he went, there weren't ships that were really designed for the Atlantic. But, once Europeans became transatlantic in civilization, they moved from these little Mediterranean and coastal ships that Columbus used to 3-masted caravels that could deal with the Atlantic properly, and then later on clipper ships, and then steamboats and ocean liners and Boeing 747s. And that's how it's going to be in space.
Do you think there's any place? Do you think interstellar colonies will be more ideal than Mars colonies once we have effective means?
Look, the interstellar colonies, first of all, they're going to be done by a civilization that is more technologically advanced than the first Mars settlements. And they will have the experience of Mars behind them. And also, frankly, probably if we're talking interstellar travel, we'll have a wider choice of planets to go to. And so we'll be able to choose some that are better than Mars in terms of their prospects they offer. So, yeah, I think The interstellar travels will have a much longer voyage, but I think they'll have a much easier time with it when they get there.
And do you see any private companies trying to do direct nuclear propulsion in the near future?
No, I mean, there's some that say they do, but the problem you have with nuclear fission propulsion is requires access to controlled materials, and whereas fusion does not, by the way. And so there's that. This is one reason why I believe that the Humans to Mars program needs to be a public-private partnership, because there are parts of what Musk needs, such as surface nuclear power, that would be very difficult for SpaceX to develop.
And so you talk about these Mars colonies. How do you think they're going to be able to, like, what particular resource do you think will be vital for them to develop these colonies for like building and construction?
Well, sure. There's going to be a lot of construction on Mars. And, I actually, not too long ago, read a book about who came to America in the colonial period. That is, the British actually kept records of who was on the ships in the 1700s, not in the 1600s. But by the mid 1700s, there's actually records of the people that came to America during the late colonial period. And it's interesting, even though the large majority of people in England at that time were farmers, the large majority of people that came to America were tradesmen, craftsmen, smiths, carpenters, masons, bricklayers. People basically engaged in building things and houses and larger buildings. And well, that's because there was a lot more of that going on in America than in England. Cities were being built. And so this course certainly was compelling to artisans. And so I think actually there's going to be a lot of people in the building trades going to Mars.
And do you think there's going to be any advancements in industry as a result of these Mars colonies?
Sure. There's going to be a lot of pressure on Mars to invent things. First of all, Mars is going to have a shortage of agricultural land because it all has to be in greenhouses. So I think they're going to be really pushing genetic engineering to get ultra productive crops. Secondly, there's going to be a big labor shortage on Mars, as there was in colonial and 19th century America, which is one of the reasons why pay here was much higher than Europe, which of course was a draw. But yeah, labor shortage is very good for working people, and for employers, what it means is you have to maximize productivity. So in 19th century America, we had the big push for labor-saving machinery. We became famous for that kind of thing. And there will still be that, of course, on Mars, labor-saving machinery, but also things like automation, robotics, artificial intelligence, all these things that multiply the productivity of labor. And then there'll be things like fusion power. On Earth, look, we can still just burn fossil fuels. Get right down to it. It's here, they're cheap. Why not? It's very difficult to displace. But on Mars, they won't have that option. And you can make fossil fuels on Mars if you have another power source, but it requires power to make them. So fusion. So Mars is going to be an engine of invention, and the inventions that Mars makes to meet its own needs will have tremendous benefits for Earth.
What's your thoughts on the idea of using of colonizing Venus through the and living around the atmosphere?
Well, I'm not that much of a fan of that. I think it'll happen eventually, but the first thing you got to do with Venus is cool it down. This could be done by putting sunshades in front of it, or even maybe orbiting it with dust clouds. Might do it, but people talk about, well, we could float cities at the 1 atmosphere level in Venus's atmosphere, and there it's not that hot, but you don't really have access to the ground. And I don't think it's that attractive a proposition.
How about the idea of colonizing Saturn's largest moon, Titan?
Well, that's of some interest for sure. Titan would be fun. On Titan, the atmosphere is 4 times as thick as Earth, and the gravity is 1/7 as much. So on Titan, you could strap wings on your arms and fly like a bird. That'd be fun.
And is there any other particular places in the solar system do you think would be a great use of colonizing?
Well, I think there'll be a lot of settlements among the asteroids. There's thousands of sizable asteroids, and people talk about mining them, and I think people will mine them, but I don't really think we're going to go there to mine them. We're going to mine them in order to go there. That is, I think there's always going to be people that want to live in a different way. They want to have a place of their own. They want to be able to make their own world. And, well, first Mars, but then the asteroids will provide people with such places. And then once you're there, you figure out how to make a living. In other words, there's people who live in the north of Finland, and they make their living by hunting reindeer. Now, they're not living there because they did a business analysis and they found that this was the most profitable occupation that you could have, would be a reindeer hunter. They wanted to live in northern Finland. They wanted to have a certain way of life, and they support it by hunting reindeer. Okay? In other words, you don't live to work, you work to live. So similarly, people want to have their own world on an asteroid to figure out how to generate the sufficient cash to make it happen.
And what's your message for anybody who wants to live off of Earth?
You want to live off of Earth? Well, the first thing you need to do is make it possible for people to live off of Earth. So, first of all, if you've got technical smarts, develop them and become part of this company of heroes that is developing the technologies to make this possible. And if you don't have technical smarts, figure out how you can help them. People who can write, people who can be filmmakers, anything that helps spread the word. Wars are not only won by soldiers, they're also won by army recruiters. So help recruit the force that will take us to Mars.
Thank you so much for coming on here. You inspired students like me to become engineers. So thank you so much.
It's my pleasure. Really enjoyed this. And once again, as you pointed out, I have a recent book called The Case for Space, which talks about a lot of this. And also an earlier book that focuses on Mars called The Case for Mars. And if people want to know more, I suggest they pick them up.
So thank you so much. It was a privilege to have you on here.
Thank you very much, Dr. Zubrin, for your time and knowledge. And I hope you all enjoyed.
Versus